Okay, so number 52, we're trying to see where f of x and g of x are parallel, or they have parallel tangent lines. So not the functions themselves, but where the slopes of their tangent lines are parallel. So I need to find where f prime of x is equal to g prime of x. Okay, so this particular x value is what we're going to look for from a to e, which will tell us when these slopes are equal. So I need to differentiate both. So f prime of x is going to use exponential differentiation, which is, first of all, I'm going to constant multiple roll out this 3. So I'm not really looking at it right now. I'm just going to say carbon copy times the natural log of the base, which is just 1, times the derivative of the power, and then we're going to multiply this 3 back in. We will get 6e to the 2x. This is f prime of x. Now we want to see what g prime of x is. Well, g of x is going to show that it's going to be just regular power rule. So g prime of x is going to equal 18x squared. Where these two equal each other, that's where my intersection will happen. And that's what my answer will be, giving me two parallel lines here and here. Okay, so if I'm looking at trying to solve x, now if I set them equal to 0, 18x squared, and I divide by 6, I'm going to get 3x squared, and then I get e to the 2x. By now, you should notice it's going to be impossible to get these x's alone to where it's just x equals something. Because if I take, let's say, the natural log to cancel out this e, the 2 comes downstairs, and we have natural log of 3x squared. And then finally, if I divide by 2, I'm still going to have some form of two x's that are separated. They're not together. The only time when you see x squared and x that you can actually solve for x's is when it's quadratic. But here it's not quadratic. It's although it's x squared, it's going to be natural log. So this is when I identify it's a calculator problem, and I'm going to straight up put these in the calculator and solve for the intersection. So let's first put in y1. We're going to put 6e to the 2x. Okay, so 6e to the 2x is in y1. And then y2 is going to be, or y4 actually is going to be 18x squared. Now y2 and y3 are off right now, so only y1 and y4 will graph. So if I press zoom 6 for my standard window, because there's no trigonometric functions, or there aren't any trigonometric functions, I just need to solve for their intersection. So if I were to zoom in, zoom to, enter, here's this first one, and here comes the second one. I can use the zoom in key. Sometimes it will work as far as displaying a better picture. I can also use zoom decimal, zoom 4, because zoom 4 will actually give a better zoomed picture sometimes instead of the zoom in. It looks like my intersection is going to occur here. Now, last but not least, I can change it still to stretch out so that I can possibly see it. I'm just playing with the calculator right now, showing you different things that you can do to the window so that you can see this intersection. So stretching it horizontally, let's make my minimum x value -2 and my maximum 2. Okay, so x value, let's put it at -2, and let's put our x max at +2, so that when we're looking at our graph, it's stretched out a little bit more, and we see this intersection occurring somewhere here. Alright, so second calc 5, and we can just say enter, enter, enter. It will give me at -0.391. -0.391, C is the answer.